Imagine a customer places an order for a veg burger and french fries using a food delivery app. Within few seconds, business users want to know, has the order been received? Which restaurant generated revenue? Which menu items are selling the most? Is this customer becoming loyal? What do customers think about this restaurant? Hello guys, welcome back to my YouTube channel. In today's video, I'll show how this entire journey happens inside Azure Databricks using an end-to-end modern Lakehouse architecture. The project follows the Medallion architecture. There are two independent data sources. The first source is a batch data consisting of customers, restaurants, menu items, and customer reviews. These are periodically received as a CSV files. The second source is a streaming data source. Instead of manually inserting records, I am injecting the orders data through a Python script that continuously generates realistic restaurant ordered events. Each generated event contains customer information, restaurant information, ordered menu items, payment methods, quantity, total amount, and timestamps. The application continuously pushes these events into Azure Event Hub. Azure Event Hub exposes Kafka compatible endpoints, allowing streaming applications to publish events effectively. Databricks continuously consumes these events using Spark structured streaming. Once the data enters Databricks, it follows through bronze, silver, and gold layers before finally powering interactive Databricks dashboards. Let's dive into the demo of the application. Before that, as I said, we do have two types of data sources. One is static batch data, and see here this batch data we are getting in the form of CSV, and we are reading these CSV files, and we are storing in the bronze table as our delta tables. When it comes to the streaming data, as I was running my Python script in my VS Code, it is continuously pushing orders items into my application, into my events hub. If you can see, the latest item is showing as 1993. I mean, the latest order is 1993. Let me refresh this page and we'll see whether we are receiving the new order items or not. So if I see my events now, obviously the order count will be increased as it continues to get the orders from the Python script. See, now the order count is 2103. So this is how the streaming data continuously comes to our event hub, and from this event hub we are injecting the data into the orders table. See, this is the code which we are using in order to get our streaming data source, and we are storing in the orders table. Okay, so we just see how the batch data and streaming data is entering into the bronze layer. I mean, into the Databricks first. Then we'll see what all the transformations we are performing under the silver layer. So as we are not performing anything under the bronze layer, as we are just keeping the data which is coming from the different sources, we are just keeping them uh, in our catalog and in our catalog. So from silver layer, we are going to perform the transformations, and we make the data clean and neat, and it should be processed in order to consume or going to be processed again and the downstream. So see, let's take an example for one of the table called orders itself. So we are just reading the streaming data from bronze orders, and we are applying some constraints over it, and we are storing in the silver fact orders. We are making that orders, and we are making it as a fact table, and we are selecting the required columns, and we are changing some of the columns as we need in our downstream tables. It applies same for the orders also, and for order items also the same structure will apply. But for fact reviews I did something different. So what we are reading here is, see here we are reading bronze reviews. So these reviews are very static. I mean, it is this CSV file I think contains all the reviews data as a textual formats, and there is no categorization or sentiment analysis was performed on it. So it is very clubbed information. We need to get some output, or we need to get what are the categories, what are the issues. I mean, we just need to categorize the reviews into some helpful format. For this one, we'll be using Mosaic AI. Let me show how this Mosaic AI syntax will look like. So it will, this syntax will look like this. So the first parameter is what is the um, model which you are going to use under in order to perform this AI query. The second parameter is prompt. So our prompt is something like this. So what is happening is we see that review text is contains many of the things, but we don't know like whether it is review is whether it is bad or negative. I mean, sorry, whether it is good or negative, it is positive or negative, or whether it is issue related to some food quality or some other delivery issues, a kind of. So we just need to categorize them into our sentiments first. So we our sentiment should be either positive, neutral, or negative, and we are categorizing the issues into multiple formats like issue related to delivery, food quality, pricing, or portion size. And thus this AI query response will something will look like this. It is a JSON with the sentiment, either it is a negative, positive, and it is if the issue with the delivery, then it this way we are making it as true, and we are showing the actual reason why the customer reviewed it as a negative. So this is what it gonna reply. So this is how the data is being transformed in the silver layer. So when it comes to transformations under gold layer, we are making it as a unified, like we are getting based on the data which we get from the silver layer, we are even more enhancing the data. Like in customer 360, what we are doing is we are combining, like we are joining multiple tables, like customer tables, and we are let me open and show it. That would be easy. See, what we are doing is we are just creating a views by joining multiple tables. See, if what in this specific file, what we are doing is for every customer, we are getting how many are his positive reviews, what are his or her. Like for a customer, we are categorizing what is reviews, and from where and all he placed the orders, and what is his favorite item, or something like we are categorizing, we are combining and categorizing the data which is specific to for each users. This is what we are doing in the customer 360 table. In the same way, we are performing, we are categorizing, I mean, we are combining the multiple tables, and we are getting some useful insights from the restaurants and reviews by combining or by joining them here. This is how we are transforming the data in the gold layer. For all these things, I have been using the pipelines in order to perform all these operations. So once we make a trigger or something, like it will do all the transformations on daily basis or on the specific time which we actually told to it. So after that, what we are doing is we are just using that data, and we are creating customer-centric dashboards using the Databricks. So this restaurant, I just developed two dashboards. One is restaurant analytics, where we can get all the restaurant-related data, like how many, what all the total orders, average order value, unique customers, and as I'm using some synthetic data, there is some decline. There is no data in some dates. But if you see the September 16, 2025, the average order value is 180 and total orders is 51. And if we see what all the top 10 selling items, and we can see what is the day-wise order, where it is, and we have peak hour analysis also by using some heat map. So this is what like we can get from all the transformations. I mean, this is how we transformed all our data from the very raw data CSV or streaming data to the helpful, very helpful insights. And if you go to the customer reviews, like here we have different, as again I used only uh, ca- it is not the real data. It is I'm just mimicking the data using some restaurants only. So if these ratings are, or these KPIs are based on the restaurant. So for each restaurant, what are the total number of reviews, and what is the average rating for that restaurant, where it is located, and what are the, I mean, what is the count of positive reviews, and what is the count of neutral reviews, and what is the count of negative reviews. And here we can see like that. the same thing in the form of line chart. And here we can see the reviews also, like what they have posted for each restaurant. Or here we are showing for all the restaurant. Let me uh, drive down to any one specific restaurant. Let's say Spice Route Mall of Emirates. We can see it will be calculated. So this restaurant is located on Dubai, and this restaurant has of total 14 reviews and average rating of 3.86. So in this restaurant, we can even see the reviews, like what is his I mean the customer reviews here. So he liked the paneer tikka, butter naan, and sweet lassi more, and it has this restaurant also has some bad reviews because of some reason which user found. This is what I have this is how I transformed all the data which we are receiving from the raw data to the actual insights which we gonna develop. So to summarize, this project demonstrates a complete enterprise style lakehouse architecture built using Azure Databricks, starting with the batch master data and continuously generated streaming events from Python application through the Azure Event Hub. Data is ingested into bronze. Data is being ingested into the bronze layer and being transformed in the silver layer using some silver data sets and enriched using Databricks Mosaic AI for customer sentiment analysis, aggregated into gold business models, and finally visualized through interactive Databricks dashboards. The architecture demonstrates how batch processing, real-time streaming, AI-powered analytics, and business intelligence can be combined into a single scalable data platform. Thank you for watching.